This is the chapter assignment, chapter 10, problem 7. We have data for credit card expenditures for groceries in population 1 and dining out in population 2. They give us the sample mean difference, which implies that this is a matched sample, which means we're looking at what people spent on groceries and what those same people spent on dining out. And the average of those differences is 850. Standard deviation, 1123. So we want to formulate a hypothesis test for no difference between the population means. So this mu is the population mean of the difference. So we're saying that the difference would be equal to 0. The alternative is that the difference is not equal to 0, which would make this a two-tailed test. So I'll show you that that's correct first. And then we'll move on to how we solve the problem. So we want an alpha of 0.05, and we want to test whether or not the population means differ. Well, that's a hypothesis test for a simple mean. We would use the hypothesis test for a mean sigma unknown. In this case, the standard mean would be 0, sample size 42, sample mean 850, sample standard deviation 1123, 0.05 level of significance, gives us a very small p-value, a calculated t-value of 4.9, with a critical t-value of 2.0195, or if you're using the table, you'll find 2.02 as that critical t-value at 41 degrees of freedom and a area in the upper tail of 0.025 if you look in the table. But obviously we have a very small p-value, 1.5 times 10 to the negative 5, certainly less than our level of significance, so we would reject h sub 0 and conclude that the difference is not equal to 0. When we come back, answer here is that the means do differ. The p-value 0.00015. Need another 0. So in this case, because the difference is not equal to 0 and we're comparing the groceries to dining out, we would conclude that the groceries would have a higher population mean. Even though we don't have the data, we can make that conclusion. And our point estimate of that difference is actually what we were given as the difference. The average difference is our point estimate, our best point estimate of the difference is 850. Now, this last part is problematic. What is a 95% confidence interval estimate of the difference between the population means? Now, in the book, they give you the impression that you can use the confidence interval estimate for a mean. Using the tool, I would use my confidence interval for mean where sigma is unknown. Sample size of 42, sample mean of 850, sample standard deviation of 1123. Of course, you could do this manually if you want. Entering in the confidence coefficient of 0.95, level of significance 0.05 gives us that same critical value of 2.02 if you round it off to 2 decimal places, which gives you then a confidence interval of 500 to round it to the nearest whole number, 1200 if we round this to the nearest whole number. But I have tried it different ways, and I can't get it to take either. So there must be something different about the way this particular author wants this input. Because I believe the answer should be 500 to 1200. But that's going to be marked wrong. And I've tried variations. A number of different ways, but I'm still not getting this number. The number that they consider to be correct. So I have to discuss this with you to see what I'm missing.